Howdy, folks. Mr. Dell here. We are going to talk about probability, specifically probability using a deck of cards. So one of the things is understanding a standard deck of cards. So hopefully within this video, if you do not know some of the numbers, you will hear and learn those things as I work through some of these problems. So probability with the standard deck of cards. So I'm taking this problem from CPM Course 2, Section 5.2.1. All right, and this is 5-30. So it says, imagine a deck of cards with all the aces and twos removed. All right, so we understand a deck of cards. There are 4 aces and 4 twos, right? There's 4 aces and 4 twos. So the standard deck of cards normally have, so a standard deck is normally total of 52 cards. But we've taken out 8 of them. So that's no longer the standard because we just subtracted 8. So a total of 52 cards is a standard deck. So before I get into the probabilities of each of these situations, I want to remind you what probability is, right? So probability is your desired outcomes. Basically what you're asking about all over the total possible outcomes. If it was a standard deck of cards, it would be 52 cards, would be the total possible outcomes. But in this case, my total possible outcomes is going to be 52 minus 8. Right? With the aces removed and the twos removed, now my total possible is equal to 44, because I just took out aces and twos. I took out 8. I did 52 minus 8 to get the 44. Okay, so A, let's look at A then. A says, what's the probability of pulling a heart out of the deck? Well, normally, again, with hearts, normally there are 4. There's first of all, with a standard deck of cards, there's 4 suits. Make sure we understand that. Standard deck. There are 4 suits, right? The suits are hearts, spades, clubs, and diamonds. And there, with the 4 suits, there's 13 of each. There's 13 hearts, 13 spades, 13 clubs, and 13 diamonds, right? So here's what's interesting is when we think about this probability here, first of all, I know what my denominator is going to be. It's going to be 44 because that's my new possible because I took out all the aces and all the twos. Well, if I took all the aces and all the twos out, I also took out the ace of hearts and the 2 of hearts. So no longer are there 13 hearts, there are 11 hearts. So the probability of getting a heart is 11 over 44 or 1/4, right? 11 can divide out. Okay, so that's A. What about B? B says the probability of a black. Well, again, a black happens to be the spades and the clubs are both black. Spades and clubs are black. And that's half the deck. So if I've taken out, again, if my total is 44, because that's what I have left after taking out the aces and the aces and twos. Well, there's 2 black aces and 2 black twos. So I've taken 4 of those out. So normally there would have been 26 black cards, but I've taken out 4 of them, so there's only 22. So 22 over 44, or 1/2. Okay, so that's the probability of a black card. So then C wants to know what's the probability of a face card. Well, face cards. Okay, what are face cards? So face cards are your jacks, your queens, and your kings. Okay, and what do we know? There's 4 of each of them. There's 4 jacks, 4 queens, and 4 kings. All right, those are the face cards. Everything else is numbered. Aces aren't considered face cards. So how many face cards do I have? Because these are the ones that have faces, right? Jacks have faces, queens have faces, kings have faces. That's why we call them face cards. So how many face cards? There's 12 face cards. They're all still in there because all he took out was the aces and twos. So there's 12 over, and again, the 44 that's left in the deck. If I'm going to simplify this, let's see, I believe excuse me, 4 goes in each of these. So that becomes 3 over 11. If I divide 4 into top and bottom. All right, and D, let's go back to D. D is a little longer. It says, how is the face card different with this deck from the probability if the deck was not missing any cards? What is the probability? Which probability is greater? So they want us to find, this is the probability of the face card given our deck without, our non-standard deck. So for D, what's the probability of getting a face card from a standard deck? Right? Probability of getting a face card from a standard deck. Well, that's just going to change my denominator, because now my denominator is 52, because that's a standard deck, and there's still 12 face cards, aren't there? So if I'm going to simplify that, I can still divide by 4. 12 divided by 4 is 3. 52 divided by 4 is 13. So it asks the question of which probability is greater. Is 3/11ths greater or 3/13ths? Well, 3/11ths is greater, isn't it? Because you're taking 3 from a smaller total. So 3/11ths is bigger than 3/13ths. So we would say that 3/11ths is greater than 3/13ths. Okay? And the reason why is because your total is less. Why? Because total is less, right? All right. And last one, E. Last number, E. E wants the probability of not a heart. Not a heart. So we're looking at, again, the standard, or not the standard deck, the new deck with aces and twos removed, not a heart. Well, interesting with not a heart, when we talk about the probability of something that is not, right? That is the opposite of if it was. And we already figured that out earlier on part A, correct? So we're really talking about what they call as the complement. So this is the complement of the probability of a heart, right? Complement is the other part of it where they add to 1 in this case. So what do we know? We know that the probability of getting a heart was 11 out of 44. Therefore, the probability of not a heart would be 33 out of 44. Because this is 11 out of 44. So it's going to be all the others, not a heart. All the other cards, 33 out of 44. So it's the complement, which that then simplifies to be 3/4. All right, there you go.